in Module 3, we're going to start talking about proofs, and we're going to start in Section 1 with algebraic proofs. And everything we learn about algebraic proofs, we can also use later on in this module as well as future modules as well. So, when we prove something in geometry, it means backing up our logic with reasons. And first, we're going to take a look at how we do this in algebra. So, an algebraic proof, it shows the logical arguments behind an algebraic solution and the reasoning behind each step. So typically, if we're solving an algebraic equation, we just solve it without thinking about how we got to that solution. And a proof shows us those reasonings. So some of those reasonings are listed here, which may be familiar to you from Algebra 1. The addition property, which states if I add the same number to both sides, I'm allowed to do that. Subtraction, I can subtract the same number from both sides. Multiplication, you can multiply both sides by the same number as long as it's not 0. Same with division, you can divide both sides of an equation by the same number as long as it's not 0. Distributive property, if you have a number outside a set of parentheses, you can multiply it into that set of parentheses. Substitution, if you have a statement that's equal, you can take one side and substitute it for another in any expression. And then the symmetric property, which says if A equals B, then B equals A. It means if I have two things that are the same, I can change the order that it's written. And we're going to be using these properties not only in Section 1, but also in later sections as well. They are not solely used for algebraic proofs, but they are most common. So what we're going to do is use something called a two-column proof when we prove these statements. So a two-column proof, it's pretty self-explanatory. It's going to have two columns. One column is going to be our statements column, and we're going to have all our statements, and the other column is going to be our reasons, which is where we're going to put all our reasons, such as those that we just talked about. So the statements they're going to be the steps that we use in solving our algebraic statement. So typically you say, okay, if 2x plus 1 equals 7, then you'd say, okay, my next statement would be 2x equals 6, and then x equals 3. Those are the statements that we use, and then the reasoning would be like, how did you get to each of those steps? So the reasons are mathematical concepts or rules that we use to back up our steps. Okay. The first statement in a proof is what is given to you. Okay. You always have to start somewhere in a proof, and you always start with what you're initially given. And this statement given is also the first reason you have as well. So let's take a look at some proof. So if I want to solve the equation 4x plus 2 equals 3x minus 6, you guys would typically just go ahead and solve the equation, but let's take a look at the reasons for each of the steps. So we want to start with what we're given. And what we're given is our equation. 4x plus 2 equals 3x minus 6. Even though it's not said, oh, this is what you're given, that's what we're starting with. Its reason would be given. That's what we have. Yeah. Next, we want to work on solving for x. Okay. There's a couple different ways you could go about it, but I want to say let's add 6 to both sides. So when I do that, we get 4x plus 8 equals 3x. And the reason would be the addition property, because I added the same number to both sides. Okay. Now I want to work on getting x by itself, so I could subtract 4x from both sides. So I can get 8 equals negative x. That's what I get when I subtract. So that reason would be the subtraction property. And typically, x can't be negative, so my last step would divide both sides by a -1, so that I get negative 8 equals x. And my reason would be the division property. And this isn't the only way to solve the equation in a proof, but it is one of the ways. So we don't usually think about the reasons behind when we solve an equation, we just do it. But it's nice to actually think about what allows me to go from one step to another. So next we want to solve the equation 3 times 2x minus 4 plus 4x equals 18. So I want to start with what we're given. So our initial equation, 3 times 2x minus 4 plus 4x equals 18. And that would be given. I'm going to go ahead and distribute the 3 in the parentheses. So we get 6x minus 12 plus 4x equals 18. So that would be the distributive property. For the reason. And before I do anything else, I'm going to combine like terms. So 6x plus 4x is 10x. So we have 10x minus 12 equals 18. And there wasn't really a reason that we talked about on the front page that would do that, but this is just, you can think of it as simplifying. Since I combined like terms, I simplified that left side. Now I can say, okay, let's add the 12 to both sides. So we get 10x equals 30. And my reason I added, so it would be the addition property. And lastly, to finally solve for x, I'm going to divide both sides by 10, so we get x equals 3, and I divided, so the reason would be the division property. Okay, the last example on this page is to solve the equation 4 times 5x minus 9 equals -2 times x plus 7. So first statement, 4 times 5x minus 9 equals -2x plus 7. And that would be what we're given. So now I want to distribute my 4 and -2 into their parentheses. So we're going to 20x minus 36 equals -2x minus 14. And the reason would be the distributive property. Okay. Now I want to work on solving my equation. So first I'm going to go ahead and add 36 to both sides. So we're going to get 20x equals -2x plus 22. And the reason would be the addition property. Next, I want to get all my variables on the same side, so I'm going to add 2x to both sides. So we're going to get 22x equals 22, and the reason is going to be, again, the addition property. And lastly, we're going to divide both sides by 22, so we get x equals 1 as our final solution, and the reason would be the division property. So in these proofs, we didn't know what our final statement was going to be since we were solving the equation. We're not entirely sure that that's what we were trying to prove because we were just solving the equation. But another way you can see a proof is being told what you're trying to prove, which is what we're going to take a look at next. So in the next proof, we're given 2x minus 80 equals 3 times x minus 2. We want to prove x equals negative 74. So the nice thing about this type of proof is we know what our last statement should be. This is what we should end up with, which is nice since you know if you don't get that you've made a mistake somewhere in a calculation and you know you have to fix it. So we're actually given our initial statement. It says the word given here. So we know 2x minus 80 equals 3 times x minus 2 is our given, since it specifically says it. Now the rest of our proof is going to look very similar to our previous ones. I'm going to distribute the 3, so we get 2x minus 80 equals 3x minus 6. Because I distributed, the reason is going to be the distributive property. Next, I'm going to go ahead and add 80 to both sides. So we get 2x equals 3x plus 74. And because I added, it would be the addition property. Next, I'm going to subtract 3x from both sides. So we get negative x equals 74. Because of the subtraction property. And then I'm going to divide both sides by negative 1, so I have a positive x, and we get x equals negative 74 because of the division property. And we have proof that x equals negative 74, which is what we wanted to do. And we know our proof is finished. We can also be asked to complete proofs, which means filling out missing pieces of information, whether it's a statement or a reason that we're missing in our proof. So we're given that 4x plus 8 equals x plus 2, and we want to prove x equals negative 2. So our very first statement here, 4x plus 8 equals x plus 2, the reason we have that statement is because it's our given. So that would be the reason. And my next statement here says 4x plus 8 equals x plus 2, and I'm subtracting x from both sides. So the reason would be the subtraction property, since that's what we're using in this step. Okay, and then we have 3x plus 8 equals 2, which is substitution because when we subtracted x, it's still equal on both sides. Next, we want to use the subtraction property again. Well, the only thing that conceivably can be subtracted is the 8, since we already subtracted our variables. So we'll have 3x plus 8 equals 2, and we're going to subtract 8 from both sides. And our next statement should be this statement we get when we subtract 8 from both sides. So we're going to have 3x equals negative 6. And we're already given its reason. So next in statement 6, we have 3x divided by 3 equals negative 6 divided by 3. Well, I'm dividing both sides. So it's going to be the division property. And then our last statement should be what we get when we do that division, which is x equals negative 2, which is what we were trying to prove, so we know we are finished with our proof. Please let me know if you have any questions over this. I know proofs are confusing sometimes. Please, please, please ask for help when you're completing the assignment so that you I know that you are understanding how to complete proofs.